Alright, this video is designed for those of you that are working on the inductive reasoning / Venn diagrams practice worksheet, and you would like to do the problems with the asterisks next to them together. So the first problem says to identify the hypothesis and the conclusion of each conditional. Remember, your conditional is an if-then statement, and the hypothesis is everything that follows the word if before the then, and the conclusion is everything that follows the word then. Okay, I just want to make sure that you remember that your hypothesis is represented by the letter P, and it does not include the word if. So don't write if in front of your hypothesis. And the conclusion is represented by the letter Q, and you do not write the word then in front of your conclusion. Number 3 wants us to write the sentence as a conditional. If you recall, a conditional is an if, keeping at me, is an if-then statement. So we're going to take this sentence that Thanksgiving in the United States falls on the 4th Thursday of November, and we're going to turn it into an if-then statement. Remember, your conditional has to make sense and it has to be true. So there's actually two ways that we can represent this sentence as a conditional. So the first way we can represent this sentence as a conditional is if we put it in the exact order that we read it. If it is Thanksgiving in the United States, then it is the 4th Thursday of November. But since reading it backwards is also true, we can write that as a conditional and say that if it is the 4th Thursday of November, then it is Thanksgiving in the United States. And that is true. When it's the 4th Thursday of November, it's Thanksgiving in the United States. It makes sense and it's true. So either one of these answers is acceptable. Number 6, we want to determine if the conditional is true or false. If it's false, provide a counterexample. Remember, you cannot provide a counterexample for something that is true, because the definition of a counterexample says that you're proving a statement is false. So if this is true, then there should be no counterexample. Let's read the statement. If a polygon has 8 sides, then it is an octagon. Well, for those of you that know what a polygon is and an 8-sided polygon is, you would know that we call it an octagon. So I can't prove this false. There are no counterexamples to prove this false. I don't know any other 8-sided polygon that we can't call an octagon. So this is a true statement and there would be no counterexample. Number 8 instructs us to write a conditional statement. So once again, we are writing an if-then statement based on the Venn diagram. Let's just take a minute and look at this as an all, some, or none statement. When you have a large circle completely surrounding a smaller circle, it's actually interpreted as an all statement. So we can say that all baseball players, reading from the inside out, all baseball players are athletes. So an if-then statement that would make sense and is true based on this Venn diagram would be that if you are a baseball player, then you are an athlete. Because can you prove that false? It just makes sense. If you're a baseball player, then you're an athlete. Definition of an athlete is someone that plays sports. A baseball player is someone that plays sports. So that would be the most sensible conditional statement for this Venn diagram. Number 12, we want to draw and label a Venn diagram to illustrate the statement of all pit bulls are dogs. So remember, when you have a Venn diagram and it has all in front of it, we want to start with a large circle that completely surrounds all of a smaller circle. And if you're reading it from the inside out, anything that follows the word all should be inside the middle circle. So following the word all is pipples. So that should go in the middle circle, or the all surrounded circle. So pipples will go on the inside circle. Following that thought or idea or subject goes on the surrounding circle. So we should have dogs here. So when we read this statement or this Venn diagram, it should be true both inside to out and outside to in. If we read it inside to out, we read all pipples are dogs. And that's true. We read it outside to in. Oops. Fix that. If we read it outside to in, we read some, remember, outside to in is some dogs are pipples, and that's true as well. There are some dogs out there that are pipples. And the last problem that we're going to do together as a group is number 14. And we have not done an example like this, but hopefully with your understanding of Venn diagrams, you're able to transfer that knowledge in order to come up with an answer to each of the following questions. So the scenario that we're presented here is that Stephen has to 100 coffee drinkers whether they like cream or sugar in their coffee. According to the Venn diagram, we want to discover who likes the following situations. But let's talk about something first. He asked 100 coffee drinkers. Just looking at these three numbers, I can see right away that 16 plus 20 plus 35 doesn't equal 100 coffee drinkers. So there's one thing you're going to have to consider when you're presented a problem like that, and that is that there are people that didn't like cream or sugar, and you have to account for those people. So of the 100 people, how many of them, subtract that 71 that like cream and sugar, cream or sugar, how many of them didn't like anything in their coffee? And that's 29. So we need to put that number aside because I bet they're going to ask us about that later. So I'm just going to put that right here. All right. So now let's really digest this situation. How many people like cream? Remember when you're reading a Venn diagram, anything that is touching or not touching, but is inside the cream circle counts as a cream. So how many people like cream? Well, there's these people here who are inside the cream circle. And these 16 people only like cream. But there are an additional 20 people here that are also inside the cream people or cream circle that we have to account for. Anything inside the cream circle likes cream. So we have to add the 20 to the 16 and we get 36. There are 36 people that like cream. So the same idea applies when we ask how many people like sugar. So anybody that is inside the sugar circle is somebody that likes sugar. So let's highlight our sugar circle. Here's our sugar circle. And anybody in this sugar circle likes sugar. You got the 35 that only like sugar, and you have the 20 that like cream and sugar, but they still count as people that like sugar. So that's a total of 20 plus 35, which is 55. Okay, so the next one gets a little bit tricky, not too much trickier. And it asks how many people like sugar but not cream. So let's highlight our sugar circle. Remember, these are all the people that like sugar. But we don't want the people that also like cream. So they cannot be inside the cream circle. So anything inside the cream circle, here's the cream circle, anything inside the cream circle, which includes this 20 here, has to be eliminated from our answer. So here's the people that like cream, here's the people that like cream, here's the people that only like sugar, not cream. So that's a total of 35 people. Okay, same thing with the next problem. How many people like cream? So let's start off with highlighting the cream circle. Here's the people that like cream. Oops, that's terrible. Everybody inside the cream circle is here and here. But we don't want the people that like sugar. So of those cream people, we have to find the people that like sugar that are inside the sugar circle and eliminate them. So these 20 people are inside the cream circle, but they're also inside the sugar circle, and we want to eliminate, we want not sugar, so we want to eliminate those 20 people. We don't want anybody in the sugar circle. So we're only left with that 16. The next scenario is we want cream and sugar. So that's the conjunction of the two intersecting circles. Okay, so what we want to do is figure out how many are inside the cream circle and inside the sugar circle. So here's your cream circle. These people are inside the cream circle. These people are inside the cream circle. And let's highlight the sugar circle. These people are inside the sugar circle. These people are inside the sugar circle. How many of them are in both the cream and the sugar circle? Well, that would be the one that we highlighted both black and yellow. So that would be 20 people. All right. The last one is a little bit tricky to understand. We want to know how many people like cream or sugar. So if I told you that I like dachshunds, I'm not even going to write that. Dachshunds is a type of a dog. And I like basset hounds. Do I like dachshunds? Yes. Do I like basset hounds? Yes. Do I like both? Yes. But do I like one or the other? Yes. When you see the word or, you have to consider both scenarios. Only cream, only sugar, and both cream and sugar. So when you see the word or, you have to account for everybody that likes one, the other, or both. So these people, 16 and 20, do these people like cream? Yeah, 16 of them like cream. Do these people like cream? Yes, 20 of them like cream. They also like sugar, but they like cream. What about these people, the 35? Do they like sugar? Yeah, they like sugar. So you have to add every single person that is inside the cream, sugar, or both cream and sugar circle. So that's going to be the 16, the 20, and the 35, which is your 71. Remember, we had that 16 plus the 20 plus the 35. And that's your 71 people. So now what I recommend you do is finish up the worksheet, make sure that you understand the rest of the problems and that you're able to do them on your own. If you have any questions, turn to a neighbor or a friend or someone else in the classroom, or write your name up on the board. Let them know what worksheet you're working on, and someone will get to you shortly. Once you finish that worksheet or you feel confident enough to take the quiz, go ahead and take the quiz. Remember, you have to get passing on the quiz. If you don't, you'll have to take this whole worksheet and turn it into me in order to take the quiz again. So we definitely want to make sure we're ready to take that quiz. If you have any questions, remember to write your name, the worksheet that you're working on the board.